So now I will now switch my layout from default to 2x3. Expand your main scene, expand the environment, select the ball. So as you can see right here, we have what we call components. These are the components. Like each and every game object has a component, like transform. Some have mesh collider. So what will happen is that we will be moving this ball across our scene right here. For example, it might collide with objects such as the player, and then it must bounce back, right? Just like maybe a tennis ball, you understand? Yes. So in order to do that, we're going to use physics to be able to play with the ball around the scene, like collide with the bricks, the walls, stuff like that. So in order to use physics, we normally use in Unity what we call a rigid body. So a rigid, as you can see right there, a rigid body is the main component that enables physical behavior for the game objects. Now things to bear in mind is that it responds to the gravity collider components. Also, it is moved by the incoming collisions. These are the main important things to understand, right, when we talk about the rigid body. So other things that you can learn about this properties such as this one, kinematics, is very important, because in kinematics it removes it from the control of physical engine and allow it to be moved if kinematically from the script. So this is what we get when you deal with the rigid body. So basically it just enables physical behavior of a game object, right? So with that all in mind, if you want to add a component, as I've said, these are the components. If you want to add a component, you click on this button right here, add component, the rigid body. You can search the rigid body right here on the top, like see rigid body. You select the first one, not the second, the first one, this one for 2D. Select it. Now we've inserted the rigid body on our game object, so we can test. We can press play and check whether everything will work fine. So as you can see now, when we press play, our balls falls down, right, due to gravity, and then it then fell on top of our player, and then it stops because our player has a collider also, and then also the ball has a collider, so it will just stop on the ground right here. Now we are sure that our physics engine is working properly. So but anyway, we are not going to use into gravity on this one, right? We don't need gravity. So what you're going to do is to go under rigid properties there, where it says use gravity, disable it. We're not going to use gravity. Also, there is this property named interpolate, right? By default is none. So what you want to do is to change from none to interpolate, so that we can get that smooth movement. Smooth movement, yeah. Now, okay, now that we have rigid body, also remember that this is the brick breaker, so it will be 2D, right? It will be a 2D game. Now, if it is 2D game, I only want this ball to move along the x-axis, right, and the y-axis. So I don't need the third component, right, which is the z. So when you go under the rigid body there, under constraints, there is this property named freeze position. I only want to move along x and y, so I don't need z. Tick on the z component, right? Now this means that our game will only move along x and y. So we are done setting up our physics component, which is the rigid body. We can collapse these things right there. All right, so now go back into your script folder that we have created, double click, go into the game folder, double click, just right click on the empty space, hover your mouse over create, select C# script, select it, write ball controller, write the ball controller there, and then press enter. So as you can see there, your script is compiling, right? Once your script is done compiling, double click it to open it on your editor. So in my case, I will be using Visual Studio 2019, but you can use any editor of your choice. So I have opened my Visual Studio. Double click on your ball controller script, or double click on my ball controller script, right? Okay, so right here we have a start method, which is called start is called before the first frame update, right? But it's called once. And then we have the update method, which is called once per frame. So before we proceed, I would like to explain a little bit about this method right here. So since we're going to use physics, right, we're not going to need update method. Why? Because if you look right here, so in our case, because we're going to use physics, right, we are going to use the fixed update method, because it is frame rate is independent. It's frame rate independent, right? And it is called 50. It makes 50 calls per second, right? So when we work with stuff such as rigid bodies, we use fixed update because we are working with physics. Just remember that when we work with physics, we use the fixed update, right? rather than update method, which is called every frame, right? Yes, it might work, it will work your game if you use update, but the performance will be degraded. And your game might be slow. So remember that when you use physics, we just use the fixed update. That's it. Now, anyway, before we continue, just delete everything. Delete everything. So we're going to need some proper fields, data fields, right? So I will say private, meaning that this field will only be available in this script. So private, I'll say float, the type is float, and then I will call it speed magnitude, right? Speed magnitude. And then I would like to initialize the value to something like 25 float. It's a float variable and it's a private, but I want us to be able to modify this value on the inspector. So what is an inspector? Inspector, if you go back to our engine right here, so if we click our ball, you see right there, this is an inspector. I wanted to expose that field somewhere in the inspector so that we can modify it right here on the inspector. Like for example, if you click on this, you see we went in this rigid body. Like for example, you can modify the mass value right here. I want the same functionality. I want to be able to modify this value on the inspector. How can I do that? By using this, you type square brackets and then you write serialize field. If I serialize this field will be available on the inspector. So let's continue. I will create another field. This one will be private also, and then it will be the vector. So I will do vector 3, and then I will call it the speed vector. This one will be the speed vector, right? The speed vector. I will need another one. I will call this one private also. This one will be the rigid body. I'll call it rigid body. Now I will need to initialize some values. When our game starts, I'll need to initialize some values. So in order to do that, we need the start method. So we have this start method which is called once per frame. So I will say private void type start method, right? Now what I want to do is to get the component. I want to initialize this component right here, this one right here. So when my game started, I want to assign, I will say rigid body is equals to I'll use this method named get component, right? Component of type rigid body. Now that I've initialized my rigid body component to this field right here, data field. Anyway, the other thing that I want to initialize is the speed, right? By default, I know that my object is stationary, right? I want to give it some initial velocity on it. So we can use the same data field, which is the rigid body. I will just say rigid body dot velocity. I need the direction now. I need the direction and magnitude to give it a velocity. Remember that formula from physics. where we set velocity reduction. Okay. Let's give it direction first. I'll give it the direction. I'll just say vector 3. If I say dot, you see I get a bunch of values right here. For example, you can start with the upward direction, to the right, to the left. You get my point, but I want you to start going downward. So this is my direction. It will go downward, and then it needs a magnitude right here. So I'll multiply it by the speed magnitude. So it will go in a downward direction with the speed of 25. So by default, initially, yeah. Now remember that we are using, when we work with physics, we use the fixed update method. So I want to update our velocity in our fixed update method. So you will type private void fixed update method. So what's going on in this method? I want to update my velocity, right? So you're going to type rigid body, init free dot velocity is equals to, right? So remember already we have velocity. Initially, this is our initial velocity, right? So already we have a velocity on our object. So I want the same velocity right here for each in every frame. I'll take the same velocity. So same velocity, and then I will normalize the value. I will normalize that value. For example, right here it was 25, right? So I'm interested in the direction. So when we say normalize, then that value becomes 1, right? The magnitude becomes 1. So basically it's like I'm getting the direction from this value, right? So now that I have this thing, I can also do the same thing multiplied by the speed magnitude, right? Speed magnitude. Now, so speed magnitude. So okay, now that I have the velocity, right? I have this velocity. Now it's a vector, right? It's a vector because I'll say this is the direction in my case, right? It's a direction, and then I have the magnitude right here. So now what I'm gonna do, I'm gonna say remember that we have this speed vector, right? It's a vector 3 because it's a vector. I wanna store that vector, this vector that we have right now. It's a velocity, right? It has the magnitude in the direction. So by saying the speed vector is equals to rigid body dot velocity, right? Now I have successfully stored this thing, or you can just do it right here. You can just do it right. The speed vector is equals to this. Still the same thing. What I mean, like saying speed vector is equals to this thing. This means that, remember that when the code reads, we read the code from starting from the right? Start right here. This value, it is assigned to this value, and this value will be assigned to this value right here. Still the same thing, right? Still the same thing. We don't necessarily need this thing. So whatever. Now that I have the speed vector, I want to cover another part right now. When we collide with objects, remember I said that when this ball collides with the object, it must bounce, right? It must bounce. So let's think of a simple example, right? For example, this example of think of a light. Think of a light, right? Let me do this thing. Think of a light, right? For example, let's say we have something, a light into a mirror, right? We have a mirror, and then we have some sort of light rays. Ne? We have some sort of light rays coming, hitting the mirror, and then being reflected, right? So this will be some sort of the light. It hits the mirror, and then it bounces. It being reflected from that mirror. So that point, it hits somewhere. It hits the same point. It is the same. Let me use different color for this one. So it hits somewhere there, right? So this is the same scenario. Like we have the mirror, and then this light rays, they come, they hit the mirror, and then they are reflected from that mirror. Obviously we have some sort of the perpendicular line somewhere there, right? So this is the same concept that I'm going to use to make this ball bounce. So with all that said, there's this method we call let me see, private void on collision end, right? On collision, right? There must be a collision in order for this ball to bounce. So what we're going to do right here, I'm gonna say that I'm gonna check the same rigid body, the same velocity of our component right there. I say rigid body dot velocity, right? Now if I say the vector ray, right? Vector ray. When we say dot, there's this method called reflect, right? I'm going to use this method named reflect. So this method named reflect, as you can see there, we need the direction of the vector. We need the normal. You see, it have two overloaded parameters. Right? So what we have to do, right? We need a vector, right? The speed vector. So already we have it already, right? This is our speed vector right here. The one we change each and every frame, right? We need that vector. It's our velocity. We need to reflect it, right? So now if I copy this, paste it right there, this is the speed vector. We need the speed vector, and then we need this point of collision that I've shown you, at the point of collision, so that we can reflect from that point of collision. So we do that using this variable right there, right, named collision. So let's say collision. When you say dot, there's this property named contact, right? Click that contact. It's in some sort of an array, right? And then I just need the initial contact, the first contact point that we hit. So you press 0, right? You press 0, and then I want the normal vector from that point of contact, the normal vector. So by doing that, we have successfully reflected our velocity when it hits any object in our scene. So just save your script, and let's go back to to Unity and test whether the script will work properly or not. So now you can select your player again, select your player, and then drag and drop that script you have created. Just click and drag it right here. Just drag it and drop it right here on top of your ball. Your ball, yeah. So if now we press Control Save, and then we press play. You see, now your ball just bounced and then it disappeared from the scene, right? Because we don't have any collider, so they just hit your player and then it disappeared from the scene, right? So yeah. Okay, what I can do right now is to create some sort of walls, right? Let's create some sort of walls, or maybe okay, let's start first with the player movement, and then afterwards we will then talk about the walls and bricks, etc., stuff like that. So right now our ball successfully moves, right? So let's start first by organizing our camera. So what we're gonna do is that go to the setup right there. I want you to select the camera again. So on the Z axis, type -45, right? Type -45, so that is further away. And then let's check player. It is position. It is this -12? Okay. Yeah. Okay. Control Save. In order to move the player again, the same process. You're going to use the physics to move our player from left to right, and then we're going to use the mouse or the touch system, right? So okay, let me switch this thing to full HD, right, so that we can see properly. Okay, make sure I'm not scaling there. Okay, right. Add the components again. Name it rigid body. So right here, let me expand it again. Expand it, and then turn off gravity. Turn on is kinematics, because I'm going to use a script to move this object. So turn on the kinematics. Then let's talk about the position again. I only want to move the player from left to right, right? So I don't need to move it on the Z direction, right? I don't need to move it upward. And then also I'm not going to rotate it, so just lock everything right here, so that we can only move it along the x-axis. We cannot move it along the y you cannot move it along the Z axis. So yeah, that is the scenario. So now you're gonna click right there and then control, add another script again. So another script, name it player controller, press enter. Now just double click the script to open it on your compiler, and then we'll begin by coding the player movement. So remember that we're going to use the mouse to move the player, or the touch system. If we will be exporting to mobile, it also will work because we'll be using the mouse and the touch system are the same thing in Unity. So yeah, let's move to coding now.